Hello and welcome to the 16th Pygame tutorial video. Now what we want to do this time is we just want to make it so that our example that we did last time with all the buttons is part of our games. That we have play and quit buttons that do two different functions that we predefine. So if I scroll down a little bit, you'll see the predefined functions. We just, predefined a couple functions, then we pass those functions through our buttons, and our buttons when clicked will do those functions. And that's pretty much what we want to do. Now, in our game, we actually want this to be a play button that will play the game instead of, just printing some statement. It'll actually change some values as the game starts. And then, of course, our quit button will pretty much just call a pygame.quit and a basic quit to just kind of, exit the game. Now, to save a little bit of time, I went ahead and created a new file called clickable rect, and inside of it, I copied all of the class definitions. Now, the class definitions are just, class, name, we have the clickable rect, we have the button, and we have the text button. They're identical to the ones over in example testing, except I changed things up so that they use utils instead of the internal function getFont. They're actually calling from the util library. So we also have utils.black for a color, as well as the other color that we choose in button. And aside from those, I just copied over interact so that, we need interact to be in the things so that our clickable rect works. And of course, importing pygame and utils, so I can use utils and I can use, pygame.surface, pygame.rect, all of that good stuff. Now, let's get started with the actual thing. So I'm going to come back over to main, and we need to do a little bit more importing. So we're going to say from our new file, which is going to be clickable rect, import. What are we importing? We want to import button and text button. Because we're going to use both buttons and text buttons, are we going to use buttons? I guess we're not using buttons yet, so I guess we'll just import the text button. Because we're not using just a standard button yet, there's no reason for us to right now. So what we're going to do is we're just going to import text button because that's the one we're going to be using. It's going to have play and quit on it. So let's go up to our main menu, which is the go to menu, which is what we start in. And let's create the buttons. So in this, we want to have probably two major buttons. We want to have one called play and maybe another one called quit. I'm thinking about having, like something like instructions. I don't know. Just some type of info, I guess, would be a valid button to put here. I don't think we can use quit, so let's add a B at the end of all these to just kind of signify that they're buttons. And since the buttons, I'm going to use the game window. I'm actually going to take a copy of the game window rect this time. So I'm just going to say rect equals game window self.gamewindow.get rect. And all this is going to do is get me a copy of it so I don't have to keep calling this function right here, gamewindow.getRect. If I call it 2 times for every button getting the position on the buttons, then that's just kind of inefficient. So we're just going to call it once to grab, a copy of it, and that's going to be labeled as rect. So this is going to equal a new text button. Play button is a new text button. What goes inside the text button? Position, size, color, text, and action. So position, we want to center it. So we're going to say rect.center x for the x position and rect.center y. And remember, this is the game window rectangle, so we're just kind of getting the center of both of them. The y, however, is going to be offset. Maybe. No, I don't think I should offset this one. I think right in the center would be okay, just because the way it's currently being drawn. So that should be fine. So we have a position, we need a size. I actually like the 200 by 80 size from the example, so we'll keep those. Color, let's go with utils.green. What should this say? Play is probably a good thing to say. And what should our action be? Well, this is where it gets a bit confusing, because what we want our action to be is to set menu to false. So we want menu to just become equal to false, so when we click the play button, this while loop just drops out. That's what we want to have happen. So when we consider our action, there's a couple ways we can do this. So one way is we can create, another define something, so we can, inside of our actual game object, we can define a new function called, start play. And then this thing, all it's going to do is say self.menu equals false. And of course, we'd have to change this thing to be self.menu, self.menu. And now this will actually work. So when we click the button, all we have to call is, for our function, we're going to say self.startPlay. And that's going to be our function call. So this is the thing, when we click the button, this is what happens. And if I actually put these things down, so I comment them out so they don't consider us error anymore, and I draw these. So let's see, where are we drawing stuff? Draw our text, split the text. Should be able to say playb.update, self.gameWindow. And now this should work. Yeah, we have our play button. Probably does need to go up 100 pixels. But we have our play button. We do the same mouse over thing that we have done before. And when we click it, none type object is callable. Self.action. It can't do its self.action. Why not? Must have to do with the self function call here. Oh, I'm calling the function itself right there. I should just call it by its name. That's my mistake. So now, when we click it, yes, it works. So this is one way of doing it, if we wanted to do it that way. Now what this does is this, of course, creates the function, and the function is part of the game object, and it's just kind of always there, even though it's only used for this one very specific thing. Now, another way we can do this is we could create the function, outside of the class, and that would be very similar to our example testing, where our functions were created outside of the class, and we passed them through and we created the buttons. That's another way we can do it. Or we can do this a very strange way. So we have our rect. How about we give ourselves a little more space inside of our go to menu function and define some more functions. So define, let's call this one start play. That name kind of worked well. Start play is just going to take self.menu and set it equal to false, just like before. And now we'll just get rid of the self dot and use start play. So this does something a little bit differently. Now, this is normally much slower if you're using this for any other reason. Because, so say you had this function inside of another function, right? Just because maybe you wanted the two to interact with each other. Now, when start play is called by anything, what happens is go to menu has to be instantiated to kind of recompile start play, sort of. This is a bad way of explaining it, but basically it means in order for you to call start play, this function also has to be created. Now, that's why it's normally inefficient if you only wanted the inside function, and generally it's slower. It's better to create these as two separate things. However, because our menu is alive, this function is alive as long as we're stuck in the menu, as long as we're waiting for the player to click the play button, then we exist here. We're in this state. So because of that, having a function while we're stuck in this menu, just kind of defined here, is all right. It's not that bad because we're not jumping out of this function very often. We're only going to be here really once or maybe twice, depending if they exit the game through the main menu or not. So this just allows us to kind of store this function in here, and it doesn't really slow us down all that much. So the function we're going to use is start play for the play button, and I'll actually show that this will work. So let's run it. So we have the play button. Currently we're stuck inside the go to menu function because of the while loop. So because we're stuck in here, we don't have to constantly, recompile this kind of double function thing. So it's all right. And when we click play, we call the function and we begin playing. So let's get the other buttons. Info button, I'm going to ignore that one for now. We might come back to it. Currently I don't really see the need for an info button in this game, but maybe that's something you want. Maybe I will add one later with some instructions, but we'll see. Quit button. Quit button is also going to be a text button. So this one's going to be a text button. It's going to have the rect.center x as well as rect.center y. This one is going to be the one that's in the direct center. I'm going to actually subtract 100 pixels from the top one so that it goes up a little more. It's a little bit higher up. Let's see, same button size, 200 by 80. Call utils dot, I don't know, maybe red is a quit button. Call this one quit. And what's this one's function going to be called? We can call this one... Now what we could do is we could actually, pass it quit as a function and it will just automatically quit. However, that would leave Pygame open and we can't add to, we can't say pygame.quit as well. So what we're going to have to do is create our own, and I'm just going to call this one, quit game. And I think this one I will use the other set, the other type of this, so I'm actually going to call this one self.quitGame. Why are we getting an error here? It's because we have a random parenthesis, I guess. So self.quitGame, I'm just going to create that up here. Define quit game. Because, this is a function we use quite a bit. We say pygame.quit, and then we call the standard quit. That's a standard thing that we do, and I can actually replace all my other calls of it with just, self.quitGame. So say this happens, we can also just call self.quitGame, self.quitGame. And then way down at the bottom, we also have another call of it right here. We can also say self.quitGame. And then we just kind of, are using a function. Instead of 2 lines, we just kind of boiled it down to 1. And before we run this, we need to do one more thing. We need to draw this new button. So we have the play button updates. We can also have the quit button update. And now we have both of our buttons being drawn. And now they're a bit high up. So, of course, this is just one of those things you have to tinker with to find the positioning you actually want. But we have a play button that, starts us playing the game so we can, run around and lose lives. And then we also, once I start it again, have the quit button. Then instead of having to click the X, now we can click the quit button, and it does essentially the same thing. So there, we've implemented those buttons. If we were going to be creating a menu button, info button, then we would need a little bit more stuff to it. I think I'd want to change up how these buttons function a little bit before the end of this video since we have quite a bit of time left. I just wanted to focus on implementing the buttons, and there's something I want to change up with them. So the issue I'm having is the text button doesn't center its text because we don't know the size of the text basically. So, it's just blitting it at 1010 when it blits the text. I would rather have it blit it to the center. And also possibly scale the text so that it fits, I suppose. So when we render, we say size equals 36. Instead of having this just a solid size, have it kind of increase its size so it, fills up the text button or the button parameter. Alright, so to make it so that these buttons work a little more dynamically, I should say, what we're going to have to do is create a few more, because, how would I put this? So this text size only works, size 38 will only work for the buttons we've created. So if I say change this thing to be, 100 by 40? Keep the same ratio. Say I change it to be 100 by 40. Now let's run it. Now you're going to notice this text does not work for the button anymore because now quit, you can't clearly see it because the button is smaller. So because this text, this size only works for this, I want to change that a little bit. So I'm going to say size equals self.font size. Now I'll create that variable right up here. Self.font size equals, I'm actually going to say self.rect.height or self.rect.h stands for height. And the reason for this is generally font sizes, what they will do is the font size is like the pixel, how tall it is in pixels. So if we just say that our font size is going to be how tall our button is, then at least that's a good starting point. Now the risk of this is that the text is going to be much too long. which is what we're going to be checking for. We're going to check once the text is no longer than the button, which we anticipate it will be, then your text will fit properly. So self.textRect equals self.text.getRect, because remember self.text, the get font, the font.render actually converts it to a Pygame surface, so we can use .getRect for the text object, and then we can say while self.textrect.width is less than, or I should say while the width is greater than self.rect.width, while the text width is greater than, meaning the text doesn't fit inside the box, is greater than the width of the text box, then what do we want to do? Well, we want to say self.font size. We want to reduce the font size, so we'll go with -=2 because the font size goes down. We want to re-render the text, so self.text equals utils.getFont size equals self.font size, style equals bold, .render text true, utils black. And I messed something up because I still have these quotes everywhere. I didn't put my end quote. Alright, so what we do is, we take the font size, we render an initial text, we get the rect of that text, and then while the text rect, the width of the text is larger than the box, meaning while it doesn't fit, what we're going to do is we're going to reduce the font size with -=, and then we're going to redraw the text, and then we're going to say self.textRect equals self.text.getRect. And the reason we have to redo this is because if we're checking the old text rect every single time, then it's always going to give us, invalid data. Basically, this will be an infinite loop if this ever returns true. And then, of course, we reset the text rect and we test again until, of course, our width can then fit inside the box, in which case we break out of the loop and we have our final self.text, which we blit to the center. And the center isn't going to be 1010. What the center is going to be is it's going to be self.rect.width minus self.text.rect.width, self.rect.height minus self.text. I can spell one day, textrect.height. And what this is going to basically say is this is a little bit different centering than we did before, but where I'm going to position it is the difference between the width values and the height values. So realistically what this would do is it would center it at the bottom right corner. I suppose if I did want to center it, because you take the width, say it's 100, and the text width, which you could say is 99 or 98 or something, and then it puts it in the middle, and then the height, say the height's 60 and then 30, it's going to place it at 30, so it's always in the bottom right. So if I wanted this to be in the center, I would take half of this. So put these in parentheses and just divide by 2. Put them in parentheses. Divide by 2. And now it should work, I believe. I think that's everything. Let's test it out. There we go. Now you can see play is like fitted to the box size. Well, pretty evenly fitted. It's actually could go a little higher, but I think it's fine how it is. And then quit is also fitted to its box, even though it's smaller. So remember how we changed up the size of these? And also, if we want to change up the size again, say we wanted the play button to be 400 by 160, then it should also, readjust its text size. So there we have it. Now the play button readjusted its text size again so that of course, it kind of, the text fits to the box. So I like that much better. Now we don't have to really worry about font sizes or text sizes going through, defining them. All we have to do is create the button, and it kind of sorts out the font size it needs for the button's, width and height. Let me just reset these values to how I like them. 280, just because I think that's a pretty good ratio. We have our two buttons. We could create the info button, but we don't need to. Let me change these up. So center Y is going to be at the center, and then this one should be what, plus 100? And then maybe those will look a bit better. Yeah, they still feel a little low. Maybe 50 is the offset I need to be using. So plus 50 and then maybe minus 50 to get it the correct offset I'm looking for. Yeah, that looks okay. So then, we have our title, we have our play and quit buttons. Play plays the game, quit quits out. And that's all I'm going to do for this one. So this one's probably a bit shorter than other videos, but I just wanted to implement the buttons and get them into the menu. So now we have two working buttons for, the actual menu. What also we should probably do, what I want to do for next time is actually we'll fix a couple little things. I guess we do have lots of time. One is the player doesn't start in the center, which has been bugging me for a while, starting over on the corner. So I'm just going to change that up when we create the player object. We're going to say, let's see, where's our player object? Do we ever? Self.rect.x and y. We actually do set them equal to something. So instead of setting them, self.rect.x and y to something, let's change this up. Let's say, we know the dimensions of it, and we know we're a 100 by 100 box. So if the dimensions of the game are 1000 by 600, 450 is centered along the x, and the y is going to be, what, 350? And that should completely center us in the game. Let's test it. Play. There we go. Well, we're actually a bit low. Oh, 350. It should be 250 to be centered. And I think that was, 250. So change that real quick. So before the end of this episode, and before we actually start working or talking about what's going to happen next time, what I want to do is change up one last thing. Just kind of fix on this idea of fixing some little things. So if we come over here, we'll notice that our kind of, menu, our scoreboard type thing is just kind of eating our player when we get over to the corner. I don't necessarily want it to do that. I would rather have it just have the black, text that will, the black text will roll over us, but we won't get completely devoured by the scoreboard. So to do that, we need to go to our utils, which is where a scoreboard is hidden, and we need to do something that we did very similarly to how we handled the mousing over on the clickable rect. So with the button, if I scroll up to it, if you remember, we created this thing called overlay, and we said overlay.setAlpha to 120. So what setAlpha does is it changes the alpha density, meaning it becomes more clear or transparent instead of opaque, but this does it for the entire surface. Now, and it's for the surface when you blit it. So the only thing I'm concerned about doing is when we change the background or the white background to our scoreboard, so say the image right here, if we said self.image.set alpha, and then we wanted to set the alpha to something really low like 60, so it's hardly noticeable. What I'm worried about is when we blit the text onto the image, then it's going to change the text's alpha density as well. But I guess I'll just have to test it. And I think I might be right on this. Yeah, see how all the text is much lighter now? It's because the entire surface is having the alpha kind of be redone on it. And I don't really want that. So in order to do this instead, because what we're doing is we're blitting, all the stuff to the image, I think we're going to have to do this a little bit differently on how we draw the scoreboard. since the image.setAlpha isn't working the way I had hoped it would, I didn't think it'd work the way I wanted it to, but since it's not working, there are a couple different ways we can do this. One way is we can blit all of the text to a game window by, passing the game window through like that, and then saying game window.blit the text to a new location, which would be, like 805 and 10. Just kind of put an offset against these so it all works out. Or we can do something probably less efficient, but a little bit cooler, I suppose. So if we blit all this stuff to the game window, the problem that's going to happen is since these are becoming part of the game window's image, when our player moves around, our player will draw over the scoreboard. Now, we can do some really annoying kind of update stuff coming back to main, choosing when everything updates by just, specifically picking where stuff updates. Like, say, for example, actually, the scoreboard updates after, so I guess it would draw over it. But anyway, that way is not nearly as fun. What's much more fun is to do it a different way that's, like I said, a little bit less inefficient, but it uses some cooler things that we might look into later. So our image is going to be a little bit different. We're no longer going to set the alpha or fill its color, and we're actually going to need two different images. So let's create a new one, self.surf. It's like a background surface, so I'm just going to call it surf. This is going to be a pygame.surface of 200 by 150. Now self.image is going to become something a little bit different. This one's going to become a game window dot subsurface of the rect 800, 0, 200 wide, 150 tall. Now we just have to pass the game window to make this happen. And am I passing the game window over here? Scoreboard self.gameWindow. Yes, I am, because I tested this earlier to make sure it would work out. So we passed the game window when we create our scoreboard. And then in our scoreboard, we create our image is a subsurface of the game window at the top right corner. Now, subsurfaces basically copy and tether together the two images. So this thing's image is the top right corner. That's what this thing's image is. So that's what we're going to be drawing to the screen. Now I'm just going to have to clean up a couple other things. And I think I have to change my update a little bit. So the reason we had to create the back image is you can't blit a subsurface onto its surface. So we had to create this, self.surf so that we can say self.surf.blit self.image so that our image is on a different surface, just to kind of like hold on to it. And we're going to blit this at just 0, 0 because we don't want it to go anywhere. Self.image is then going to be blitted, not self.image, but self.surf is going to be blitted to the rectangle, which is going to be that top right corner, 800, 0. So I believe this should work. Let's test it out. Oh, something happened. Size needed to be int width, int height. Oh, these are not in a tuple form. So that's why it's giving me an error. Real quick error, easy to fix. Play the game. So what you're going to notice is when I go over this, and it's actually not working, is it? Oh, again, this is not in parentheses. So it's again not able to find the correct rectangle that it's supposed to be building the subsurface off of. So now, if all goes well, this will work. No. And one last thing, I can't be saying self.image, I have to say self.surf, fill white, just because the surface, the background is the thing that gets filled with white, not the actual image. So now, if all goes well, it will work the way I want it to. Yes, it does. Okay, so now you're noticing that this thing is drawing properly. Whereas in the last example that I just had, this wasn't working. A white box was being drawn over us. Well, To be technical with you, a white box is still being drawn over us, over our player. There's still the white box. Like if we're right here, we're completely encompassed by that white box. Our blue image actually is not shown. But the reason we're able to see ourselves is because we're using a subsurface. And that subsurface is tied to the top right corner of the game window, meaning whatever is in the top right corner of the game window is being drawn onto the subsurface that is the top right corner, that's positioned at the top right corner of this. So that almost makes no sense, so I'm just going to change this thing's position to be 400, which is the center of the screen, and I'll show you what I mean. So our scoreboard is the top right corner. See, this is the scoreboard. When we go under it, the scoreboard is in the center. When we go under it, you're going to notice that we become blocked out by the scoreboard. However, this thing on the right is also the scoreboard. It's the subsurface. So when we come over here, right, we don't get blocked out because over here the game window is sharing its surface with the scoreboard. So when we go over the scoreboard, we get, taken over, we get blacked out so that we can't see anymore, and running out of lives is starting to get a little annoying. Maybe I have to up them so I can take more hits. But the scoreboard consumes us. However, when we move over here, we get drawn over here onto the scoreboard. So our exact position is getting drawn onto the scoreboard, even though the scoreboard's covering us up. It's sort of like, kind of like a window. It's acting sort of like one because it's copying us. So even though, we get consumed by it, so we can't see, we get drawn, the scoreboard draws over us, because we're also in the top right corner, the scoreboard draws us onto itself because of the subsurface. Again, it's hard to explain without, spending a long time just showing how it works, but it, in a way, makes the scoreboard completely transparent, because even though it's drawing over us, because our character is in the same location, its image becomes that corner where our character is. I'm just going to say hopefully you understand at least a little bit with the example, but I don't know how to explain this properly. Anyway, this is all we're going to be doing for this video. Next time, what I want to work on is like a map. I want to give us a larger map to play around with. So instead of just having, this little tiny map here, instead of having this little tiny map, I want to actually have a much bigger map. So, if we come over to the edge, maybe the map will scroll so that we have more room. So instead of it just being this one little arena, we have a bit more space to actually play this game with. So that's my plans for next time. Anyway, thank you for watching. Hope to see you then.